So, kuha na lang ka ng mupadayon na lang ko lecture for siguro mga 30 minutes and will be okay for today. So, the second type of design is hindi naka-determine sa D of D, kundi magbuot na lagi kag-imong trial section dito, no? And then, with the trial section, doon na siya B, doon na siya dimension, butangan lang sa limog kabilya. Ang diferensya lang is, i-determine mo ang iyang capacity after. I-compare din mo ang capacity o ang actual na required moment. Ano lang. So, bali, the one that I first introduced is tailored, not tailored. So, pagkita ni mong B o D based on the equation, and then pagkita ni mo ang AS based on the equation. And then you have the design. Yan, the-tailored yun ni mo based on the strength. The second one is the other approach, no? That there is already a ready-made beam. The only thing magamit mo siya kung mapatunayan mo na ang iyang capacity is more than the required. So, how do you do that is, once you have already the section, you are going to investigate the moment. So, nga simple, no? So, again, we are still on designing the tension reinforcement. So, katulungan na ang compression member dili sa, because our topic is about tension reinforcement. So, it's only calculating how much tension reinforcement we need, no? But we know that dili pa gina siya human nga section kay as I have mentioned, kinahanglan pa tao compressive reinforcement, kinahanglan pa sa tao shear reinforcement. So, the topic that I discussed today is only for the amount of tension reinforcement needed in the tension side. Only the tension side. Okay. So, I will proceed to the lecture. Okay. So, this one is I will just continue it. No? Okay. So, okay. So, bali, the one that we do is the tailored one. The second type is okay, where is that one? Yeah, this is the design tailored. No, so when we say another design of tension reinforcement, this is the second type. No, I will put it here. The second type. Here, I will put it here. Okay, paste. So, design of rectangular tension member with tension one. So, this is analysis type. Analysis. So, based on assumed section. So, doon na kay trial section. Okay. So, still the moment is there. It's required, but to be determined is the trial section. What is in the trial section? You need the D, and the ES. ES ang remember tag ES, mo na siyang pinaka-symbol yun sa compressive tension reinforcement, ES. Okay. So, if I am going to make a step, so I will make maybe 2 steps only. 2 steps, no? So, 2 steps. Where is it? 2 steps only. 2 or 3. Depends, no? So, I'll move this one here. I have step 1. I have step 2. Lumaya, good na step. Okay. I-delete mo na lang. So, isa yung area. Yeah, 16. Okay, step 1. Draw. Trial section. So, trial section. Okay? So, that means I'm going to draw the D, the rectangle here, and of course, I'm going to put the ES, put the ES here. Then I should know where is the D. Say D. Yan. Ibutang salita o anin. Barandaan. Ito ay barandaan. May group. Group. Okay. So, dinina ni siya ay D, no? Nani siya ay D. D, natin siya, nani siya ay D. 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 Nani siya ay ES. Siya ay ES. ES. Okay. So, yung una ko tanga niya, B is equal to B equal to how many and B is equal to how many and kay is m squared nga tapos pag na yung pag determine no F prime C na siya i-determine may Pascal at Y Pascal dapat mo na siya imong manuna so once you have that already once you have that, you have to calculate the MN, okay, the MN, or call this nominal moment, MN, okay, or the factor, design, so the design moment, the FMN. Okay. FMN. Posible ba gagawin mo calculate? And really, no? All you have to do is to use this figure. Use this figure. We will use the figure. We will use the figure, no? Dito natin kami natin yun. Ngita lang tag witness trace diagram, no? Witness. So, ngita ta sa internet of witness trace block. Okay. We call this as witness trace block. Whitney. Witness nun ha? Whitney. Rectangular. Rectangular stress block. Kasi figure image. Lost mo dahil. Okay. Stress block. I think this one is okay. Okay, this is the Whitney stress block. But I want the stress block alone. Okay, I need a small space lang. Okay, this one. Copy. This is the Whitney stress block. Okay, that is the stress block by Whitney. Okay, so Whitney stress block. So once you have already the ES na nakay one, you're going to calculate MN. But in order to calculate the MN, you are going to calculate the A. No? A is equal to, using equation, itong A, ang tayo formula sa A, ini, using equation 3, using equation 3, na siya ang atong A, Y. Okay. Wherein ang row, makalculate mo ang row using this equation. Ang equation sa row actually. Row, this one. B is over BD. Okay. So, kaya pag anong solve sa MN, computer sa nato ang row. Makumpita na to ang row, kaya nga no, ato naman isip daan ng ESD sa atong tayong seksyon. Pati ang BD, so, makumpita na to ang row. So, makumpita na to ang A, na natay row, na natay FY, na natay B, na natay F5, so makumpita na to ang A. Then, using this stress block, ini mong distansya niya ni, ini distance from there to there is equal to D minus A D minus A divided by 2. Ano siya? Kaya nga nung E over 2 na siya, to, kaya ang C na to, naagin na sa tunga sa A, kaya rectangular mo ni, na siya diya. So, that means, kini siya din distance is E over 2, kini siya E over 2. Yan, kay D man siya tanan, kini nga distance, D man ni. Ikan diha, tayo mo din is D. Para siya, D na siya. So, ato nang butangan. D na siya. Okay, D na siya. So, pinilis as D over 2. So, ang moment, wala na. Muna to siya. D is equal to, we can use the ESF Y times D minus 0.5 of A. O 1/2 A. D over 2 lang. A divided by 2. Unang moment niya. Masolve bago nato na. Ang pangutana is solve kayo. Kaya naman, naanang tayo ES. Ato man na ang gi-assume na tayo equal. Na-compute na nato ang A, na tayo D. So, kaya asunod na dito mag-compute. But only in your trial section, check if this one is close to ES mean, is this done, ES, and this done, ES max. Mawag na ang pinaka-importante, ES mean. Check ES. Check ES. We do not know whether we are in between ES mean and ES max unless we will compute ES mean. So we will include the equation for ES mean there. We have the rho mean. We have the rho mean here, which is this one. So that will be included in step 1. Okay, rho mean. So therefore, your ES mean is equals to rho mean times BD. Okay. So, muna yung ES mean. Okay. Okay siya. Yung siya. Check. Ano siya subscript din. Okay. Which is equal to that. So, then after that, padinin din na siya dito. Padinin na siya. There it is. Your minimum reinforcement is that one. Now, you need also to determine the ES max. No? ES max is just equal to this equation. I-multiply mo siya by BD. We have ES max. And this is ES max. But the equation for rho max is we have to go back to the equation for rho max. Rho max is this one. This one, if we have to determine the rho balance. The rho balance. We have the rho balance. Okay, once you have the rho balance, you can calculate the rho max. You can calculate the rho max is equal to the 38.75 of rho balance. Okay. Once you have the rho max, so you can calculate AS max. So check if AS is AS max o ato di ba rin ito. If you find out that your AS is overshooting AS max, then you have to recalculate again. So that you can only proceed to step 2 if this one is satisfied. Then once you have already, if you already have AS satisfy this equation, then all you have to do is to calculate the MN. Then step 3, I said step 3, I will add 1. Insert rows below. Okay. Step 3. If MN is greater than MU, napag-resident inequality sign in bold. That one. This one is subscript. This one is subscript. This one is unique. So, if you find out that it is okay, then if Elimination. Then section is save. So we will have an example. I will label this one as example 1. Example 1. Okay. Then I will example, so this one is, I'll just copy that, I'll just revise it. Okay, example 2. Here, I put here. Example 2. Simple beam. Simple beam. Turning figures of the using and post concrete to develop and create and the span. The span of, you see, 8 meters. L is still the same. I'll just say 12. No, that's 10, and this one is 12. Okay. Material specification, if C5 is equals to 20 and 250, design the reinforced concrete section. Ayan, simple beam. Ayan, itatak simple beam din ni 30 minutes ba kung giingon ba. So anyway, I will go to the simple beam. Simple beam. Alam sa simple beam. Units simple beam. Pag problema lang kayo na, may load. At huwag taguan. May simple beam mo ito. Okay, na. Simple beam. So, this is the figure. Okay? Figure. Okay, so, now, the load here, WU is equal to, yes, Karna. WU is, you have 1.2D plus 1.6L. And based on the given, you have 12 times 1.6 times 12 is you have 172. 12 times 1.6 plus 12. This is 31.2 kN. Okay. On the length here. Okay. So, determining the shear diagram, we can do the shear diagram like this. This is shear, then copy. I will rotate the vertical. Rotate. That's the shear diagram. So the DU here. Okay. So the VU here, VU is equal to 31.6 times length times 4. So 126.4. Now, if we have an email in middle, MU equals to 126.4 times 2, 252, 28 pm. And so we will do the shape is the moment you like that. If you have some violent reaction, please you can interrupt. That's the shape in the moment, and the maximum moment actually exists in the middle where there is zero shear. So ano, we're just talking simple beam. Simple beam like bridges, yeah, simple beam. Okay, that's the moment. So in other words, step one, that's not part of the step one, but we need that. We need to do that. No? So that we have comparison for step three. No? So in you, we know that already, but we will reserve that to step three. Okay. Now, solution. Okay, solution. I'll just copy this one table. There are three steps already. Okay. Copy. Then I will paste it here. Okay. So, trial section, no? So easy. I will just say my B is 250 mm. 250 mm. My D is 500 mm. I will just say 450 mm. Then my E is I will try to use maybe 25 m steel reinforcement. And I will just use Canadian, no? I will be more specific, Canadian. Okay, so the area of one bar of 25 mm, and I'm going back to the table here. Okay, 25 mm is 25.2 diameter. So to compute the one area of one bar, where is it? Area of one bar is you have 5 times diameter squared. No? So first I will include dia. The dia is that 25.2. 25.2. So the area, simply the square of the diameter times pi over 4. So 25.2 squared times pi divided by 4. So I have 498.759 mm squared. Okay. 8 mm squared. So using the minimum one, so the E is mean, assuming that my B and D is equals to 250 and 450, I have 1.389 divided by 250. So I have my E is mean times BD times 250 times 450. So I have my mean as 625 mm squared. Okay, is my one. Now I did not even use pa my ES, no? So if I'm going to use ES, my ES here, so I will just specify use 8 or 625 m in forcing bars. So that means my ES is 6 times 498. So you have 498.759 times 6. I have 2,992.55 mm squared. So if I'm going to supply this I am lesser than my ESMIN? No. But I do not know from here whether I am over the ES max unless I computed it. So I can compute the row balance using this. Okay. So using the row balance, if the FC prime is still 24, 24 times 0.85 times beta 1 which is 0.85, then times 600, then I divide this by 250. Then I divide by 850 again. So I have 0.048. So my room balance is 0.04896. But we are not using row balance, we are using the row max. So I need this row max. I need the value of the row max as 0.75 of 0.4896, so times 0.75. So I have 0.3672. That's my row max. Yeah, row max. So I can compute my ES max. So I just multiply my row max by B, which is 250, and D, which is 450. So I have 4131 in m squared. Okay, m squared. So how much is I provide? I provide with 2992. So check if my ES is within this argument. So I will plot 625 as my ESN is less than my 2992.55 is less than 4131. So okay, my my reinforcement is within the ES min and the ES max. And what does it say? I am under reinforced, and that's okay. That's okay. My beam is not over stacked with rebars. That's dangerous when you overstack your concrete with rebars. So you reinforce only according to how much reinforcement is needed. So okay, so step one is okay. So I am now going to calculate my PMN. Ah, excuse. Okay. So after that, you can calculate the actual loop. Actual loop. We have 2992.55, 2992.55 divided by 250 divided by 450. My actual loop is 0.266. Okay, I can even calculate my A. My A is equal to A. So I have 2992.55 divided by 250 divided by 450.266. I will multiply that by 250, which is the FY, times 450, which is the D, divided by 0.85, divided by 24. So my E here is 146.694 in M. Okay, that is in M. So I can compute my MN. My MN is equal to, can we really calculate MN? You can. Okay, I have my ES. My ES is 2992.55 times 250, the FY, times the quantity of 450 minus 0.5 of 146.694. And the answer is 281,788,233.8 Newton meter. In terms of kilonewton meter and Newton mm. In terms of kilonewton meter, I will move the decimal place 6, 1, 2, 3, 4, 5, 6, 2, 8, 1. Or, yeah, but this is already kNm. Now, this is just the nominal. Now, if you run the design, so you need to introduce the P equals to 0.9 for binding. Okay, so reduction factor for binding. Now, the PMN is 281.70 times 0.9 is equals to 253.6 PNM. 253. If PMN is greater than, so we check if the 253.6 is greater than mu. Mu is determined in the analysis. 252. We are very lucky. Why? Usually, you need a lot of trial, but this one is, yeah, over, so this is safe. No? What if we use 5 only? So, we have a reinforcement that's lesser than 2992. So, we have a moment lesser than this, what we could have arrived here. But we are really lucky, so maybe we want to end it early. So, this one, so, step 3 is safe. So, this is the second type, the second approach to design of the tailored section. The tailored section is just basically known already using in the tenor of a dial section. But if in case step 3 fail, you go back to step 1. Okay, increase the section or either increase the steel area as long as you follow all of the rules, because there are rules. You cannot reinforce over than AS max. Okay, so that's it. So this is the process of the second approach. So that's why in my example 2, I use this one. I still analyze. You can use software in this case, but you can use also the knowledge that you have in structural theory. Then, yeah, you're able to reduce the number of steps actually here. But we are just very lucky that we hit it right away, that we never violate this argument. So we have designed a very safe section and economical as well. Okay. So I will stop. So now I will save this and post this in the upload this in the eLearn as our lecture today. So I would like to say that This afternoon, this morning, I have yeah, introduced the tailored. The other one is also tailored, but there's already need section already. All you have to do is to determine whether that complies with the requirement. And the requirement is just P in N is must be greater or equal to in mu. And in our first trial, we hit it right away. So in most cases, you have three trials before you hit. No? But you have only that is roughly simple. The first one is basically you're going to tailor the PND and the ES based on the email right away. So you have more steps there. Okay? Because balik-balik sa to sa pag-adjust nimo sa row because you need to update even the RN. But with the Excel spreadsheet, it's not really a problem. Okay. All you have to do is to embed the formula, make a template, and even if you try minute 1,000 times, so you don't do the calculation, let the Excel do that. Okay. So that's it. So that ends our lecture for this morning and afternoon. I'll say that we have a very fruitful lecture. We able to arrive our objective, which is to design beam and bending reinforced intention. Okay, we have two examples. Okay, so I will stop. So I will dismiss you. So thank you for coming. So if you have some question, please ask. Are you still there, class? Are you still awake?
Thank you, sir.
Yes, sir.
Okay, so I will just upload the lecture, huh? Okay.
Thank
So
you, sir.
okay, thank
Thank
you.
you, sir.
Thank you.
Thank you, sir.